A couple of workflows ago, we had derived the shoreline using Sentinel-2 optical satellite imagery over Anjuna beach and its surroundings in Goa, the state on the western coast of India, for the period of 2017 and 2024 respectively. This time around, we will be using another source of imagery, the Landsat 8. It also supplies optical imagery and revisits an area of interest every 16-day cycle. On board the Landsat 8 are two instruments, the Operational Land Imager or OLI, which captures reflectances across 9 spectral bands in the visible and the near visible spectrum, primarily at a 30-meter resolution per pixel. Also, it contains a thermal infrared sensor which captures temperature-related information using 2 spectral bands. So how does the Landsat 8, which is operated by USA, fare against the Sentinel-2, which is operated by European Union? One can say, as you can see in the image, they have a similar spectral profile. If you ignore the thermal sensor, which the Sentinel-2 satellite doesn't have. In terms of resolution, Sentinel-2 captures information at 10-meter resolution, 20-meter resolution, as well as 60-meter resolution. Primarily, you can say at a 20-meter resolution. So when it comes to the pixel size, it is basically Sentinel-2 has the slightly upper hand, relatively that is. Also, in terms of the revisit time, its cycle is 10 days, which is better than Landsat 8's 16-day cycle. So Landsat 8 imagery can be sourced from a variety of sources. I prefer to use Earth Explorer website managed by United States Geological Survey. To begin with, one can either choose to upload a shapefile of our area of interest, or as in our case, we'll just type in the landmark, which is Anjuna Beach, in the geocoder section, and Earth Explorer shall figure out the precise coordinates, as well as update the view of the display, which also serves as a filter. It will only show us search results which overlap this particular pin. When it comes to timeline, let's maintain consistency. Because we had downloaded Sentinel-2 imagery from 2024 in the month of January, we'll try to basically figure out Landsat 8 imagery from that particular timeline itself. Let me key in the timeline. I'll key in from Jan to March of 2024. One can also select cloud cover. In optical imagery, we need to ensure that it has a very low cloud cover. So we'll just limit it to maximum of 1%. Besides that, one can tweak with the result options, as in how many output you want in a result view. Coming to the important aspect, we'll just select which satellite imagery we want. We want the level 2 Landsat collection. Level 2 basically captures surface reflectances. Landsat 7 was discontinued in January 19, so before that the data is still available, but Landsat 8 or 9 is what is precisely suitable for us. Landsat 9 is relatively new, 2021. So upon clicking Landsat 8 or 9 level 2 product, we find that there are 7 search results. Similar to the Sentinel satellite imagery, the information is present on the screen like it was present on the Copernicus browser. We can access the metadata, observe the orbit, observe the cloud cover, and determine which product could be of use to us. This particular product has a 0% cloud cover. Now, because we are interested in January, one can see that there is a product from 11th of January in 2024. And upon observing it, it also has a very low cloud cover. In fact, it is 0. So this is a suitable imagery dataset, and one can click on the download button. The benefit of downloading Landsat imagery is one doesn't need to download the entire file. One can be selective also which bands one wants. So for shoreline delineation purposes, we need bands 2nd to 7th. So 2, 3, 4, 5, 6 and 7. Straight away it downloads the, upon clicking the download button, it downloads the bands. Each of them are basically around 60 to 70 MB in size each. Now the method of shoreline delineation is the NDVI+Tasseled Cap. So for that, we will do the study on ArcGIS Pro, and there is a particular toolbox which we need to download. The URL is mentioned on the screen. One can even Google search. So upon clicking the downloaded zip file, we will use the 10.1 to 10.2 tool. So we'll just only extract that particular tool because the others are not working. I had tested it. We'll save it in our working folder. By that time, the bands also have been downloaded. This is the entire workflow we've completed from downloading the Landsat 8 imagery, and we will now begin the processing aspect on ArcGIS Pro, beginning from clipping the raster to NDVI to a number of steps before creating the ultimate shoreline boundary from Landsat 8 imagery. If you remember, in Sentinel 2, the method was slightly different. We had done the NDWI, which is a water index. So that index basically, once we plug in the formula, delineates the water, and then we had used it to basically mask out the ocean from the land and then derive the shoreline. NDVI is basically deals with vegetation. So this time around, the method is slightly different. We'll figure out vegetation area, which would help in determining the edge of the land and subsequently the shoreline. Meanwhile, Tasseled Cap technique utilizes the multispectral band information and transforms it into three types of vegetation specific output, namely brightness, wetness and greenness products. Together, these components aid in the temporal analysis workflows, as is applicable for our shoreline delineation workflow as well. Let me transfer the downloaded Landsat 8 imagery bands into my working folder. And now we are ready to begin the processing phase on ArcGIS Pro GIS software. Let me create a new project. While ArcGIS Pro comes with preloaded geoprocessing tools and toolboxes, the NDVI+Tasseled Cap toolbox is an external toolbox and we'll have to load it separately. We can do so by clicking on Insert at the top of the screen and going to Add Toolbox section and navigating it to the location of the Save tool. Upon selecting it, it is loaded in the geoprocessing pane under our current project. As you can see, there are 7 types of tools within this particular toolbox. Now, one can load the downloaded Landsat 8 images by using the Add Data button underneath the Map tab, or simply just drag and drop it from the folder onto the content pane of ArcGIS Pro, as we will do in our case. All the products have been loaded, and these are black and white renditions, and the pixel range is also mentioned underneath each of the layer. We need not worry about the interpretation of these bands, and it is not necessary for our workflow currently. That being said, if you recollect, on Snap I had showed you the true color representation. Remember, this is an optical imagery, so we can do so in ArcGIS Pro as well. We'll have to navigate to the Imagery tab, click on Raster Functions, Data Management, then thereafter, and finally on Composite Bands. In the composite bands, it's kind of we'll use which 3 bands are needed for generating the true color imagery. So we need the B4, B3 and B2 band to basically generate a true color rendition of the area of interest in the Landsat 8 cross section. Doesn't this look beautiful? For a moment I thought this was not a true color image and it was just a piece of art, and that is often the beauty with satellite imagery. Actually, this is a natural color photograph. Where is Anjuna beach in this? We can go to the locate tool and use it to basically ascertain. This is where Anjuna beach is located, and those who have seen my previous workflows would associate the memory of this particular location. We'll create a new bookmark, which basically would help us navigate back to this location should we basically zoom in, zoom out, or go to another view. And this is particularly useful. So let me just zoom out right now. And if we go to the bookmark section and just go click on that particular bookmark we saved, it automatically zooms into the precise location. Anyways, now that we have done viewing the optical photograph and zooming it onto our area of interest, we can begin with the first geoprocessing tool in the new toolbox, which is clip multiple rasters to AoI. Over here, we can club multiple rasters together and then do it the entire batch processing of it. But for this particular workflow, let me do it individually using a different method, and it has one particular advantage also, which I later on figured out. So instead of using the first tool in the downloaded toolbox, we'll just use the clip raster tool. In the input raster, we'll have to select each of the products, the 6 imagery products, one by one. In the environment, we'll click on any one of the bands because it will select the output coordinate system of the newly generated band, which is in the UTM. It's basically a projected coordinate system. Now this is a utility of the clip raster tool. Basically, we can draw our clip raster polygon at this very juncture. This particular polygon basically is used as a subsetting tool. It basically clips the entire, this is the location where we want to basically restrict our processing to. And this particular polygon that has been generated using clip raster tool will also be used for us in our later geoprocessing on this particular workflow itself. Thereafter, we will input that particular polygon on the parameters section and subsequently name the output raster dataset as well. Now that we have done, the output has been generated. And let me close the other previously open products, and you can see that the entire range was basically subsetted to just our area of interest which we had drawn a polygon for. Similarly, we can do the same step for the other 5 imagery bands, and I'll not show each of them right now. It would be a waste of time, so I'll just quickly fast forward it to the spot when I had basically created all the 6 imagery bands clips to raster. Let me minimize the view. We don't need the dataset to be open on our view as well. So let me just close it and locate the clip raster extend polygon right at the downwardmost section of the content pane. Now that we have done with clip raster, we can do NDVI calculation, which is the tool number 4. So we'll have to input just 2 information, what is the red band and what is the near infrared band, which is band 4 and band 5 respectively. We'll name the NDVI file as per our desire and save it in a particular folder of our or database of our choice. Besides that, in the environment section, we can specify. This is not a necessary step, but then I like to be better safe than sorry. So I just click on any of the existing product and ensure that the projected coordinate system of UTM is basically selected. Thereafter, upon clicking run, the NDVI product is generated. Again, we don't need to basically involve ourselves in the interpretation of it, but we can observe that straight away the vegetation is basically highlighted in bright colors and water was basically a dark pixel. So we are quite on our way of delineating the shoreline. The next step is Landsat 8 Tasseled Cap transformation. For this tool to work without errors, we need to go first to the environment tab and update the processing extent. Fortunately, we can do so using our previously generated clip raster polygon. Subsequently, the parameters tab will work without error. As you can see, the red cross has been removed and we can plug in the input rasters against each of the respective band names specified. The clipped rasters, that is. Subsequently, we need to set the location where the newly generated output should be stored, which is the 3 vegetation bands, brightness, greenness and wetness respectively. Again, for the purpose of this shoreline delineation workflow, what these bands are in technical detail need not be understood that much. Essentially, these are vegetation related output and it will help us to delineate land from the sea. The tool is completed running and we can see that the 3 new output have been generated and located in the content pane. Now that we have generated the NDVI band as well as our 3 bands from Tasseled Cap, we are ready to pursue category creation of land and sea. In the input raster band, we will direct it to the 4 new bands, NDVI and the 3 vegetation bands. We also need to specify where ArcGIS Pro should store the ISO class and Dendrog Auto files. These files are by default saved in a temporary location and the tool won't run, but after you save it to a permanent location on your system, the tool will be able to run without error. Now that we have done so, we can rename the location and the name of the output raster, but we'll keep it as default. In the reject fraction, 0.005 is by default, and as per my understanding, we can even make it as 0.0. It wouldn't make much of a difference in terms of our overall output. In the environment tab, we'll just be cautious and update the environment to the projected coordinate system by selecting one of any of our band which is in that system. So the output has now been generated. It's a multicolored output, but soon it will begin to make sense to you. Let me update the base map from the current topography to the satellite imagery base map. Now I will play around with the transparency of this layer. Can you spot what is the output and what does it mean? Essentially, the various colors are overlaying on the ocean and the land features, and you can see that there are distinct colors allocated to them. You can clearly see that colors for value number 2 and value number 3 are located for water bodies, and for the remaining colors they are all located on the land. Now this output is not similar across any of the satellite imagery processing you do, just it is particular for our current Anjuna beach related output. So what we are doing right now is we are recoloring by using the symbology pane. So value number 2 and 3 will color it as blue because it is a water feature, and the remaining ones will color it as green because these are essentially land-based features. Now this is just not an artistic output. This particular revised symbology will be useful in our next tool also. So this particular output, which is comprising of just 2 colors with values 2 and 3 for water and the remaining for land. The classify land and sea will use this revised symbology as well as a particular values which we will specify. So in the input raster, we will use the revised symbology raster. We will name the output as reclassify and save it to our desired location. Now what we need to do over here is, for the water pixels, we need to plug in a value of 10, which is the maximum weightage. So this is the value basically. So this is where what we'll insert. So what originally carried a value of 2 and 3 will now carry a value of 10. And for all the land features, it will carry a value of 0. So essentially what we are doing is, we are masking out the land by using this particular tool. In the no data value, it can carry a value of either 0 or 10. It depends on where the majority of no data pixels are located. So no data pixels typically are for where the cloud cover is present, which basically prevents the reflectances to reach the satellite's receiver. In our case, much of the imagery was devoid of cloud cover, and therefore we can use either a value of 0 or 10. I've chosen to use a 0. Also in the environment, I'll ensure that a projected coordinate system is set as the nature of the output. Let me run the tool and quickly show you the newly generated output. While the color combination has changed slightly, the essential point of distinction is the values of the pixels have now changed. So the green colored area has a pixel value of 10, while land is colored red and it has a pixel value of 0. This conceptually draws us closer to the final step, which is the creation of the shoreline boundary using the tool number 7. We need to use the newly generated reclassified as our input raster, as well as clip it to the mask area of our interest. And fortunately, we had already generated a polygon in our first step, which we can use. Although if that is not present, you can also create a new feature class and draw a shape of polygon over the area of interest and use it as the mask in this particular tool. Subsequently, we can specify where the output shoreline will be saved. And in the number of neighbors to use, which is the algorithm, we can use either 8 or 4. Now here is the reason why I had used the word automatic or manual in the workflow image which I had shown you in the previous step. The reason being is that this tool doesn't work. At least it has not worked in my particular software, and I think it is restricted in some way for this particular software version. It is built for the older software version. Besides that, I can't think of any reason why the tool shouldn't generate a particular shoreline. So which is why I have resorted to a manual creation shoreline, because in this particular tool, the output shoreline doesn't contain any attributes, as in there is no shoreline being generated despite all the parameters being correct. And I had spent literally hours on trying to find out whether I am making a mistake or not. So that being said, this particular shoreline is not very complicated, as in there is not much curvature or not many, water bodies or flooded areas and so on. So which makes the task of manually creating a shoreline all that much easier. And we've used this step before in our previous workflows as well. So all we need to do is basically use the raster to polygon tool to first create the individual pixels into a vector shape. Subsequently, we'll use the polygon to line tool to basically break down the vector shape into vector lines. Raster to polygon conversion tool has successfully run, and the output is displayed on the map view as well as in the content pane. This is an intermediary step. We have just created a vector shapes. Upon clicking, you can see that the entire shape has been selected instead of displaying a pixel value. And information such as length and area of shape is present. There are two shapes in our layer. And you can see the outline of the shoreline as well, which we will basically extract using the polygon to line tool, which will break down the shape into individual line segments. We need to specify the parameter. Input feature is the polygon layer. We'll specify the projected coordinate system in the environment. And the new output has been generated. Subsequently, what we'll do is, you can see that there are a number of line segments. We just need to keep those of the shoreline. So upon opening the attribute table and sorting the shape length column in a descending order, we'll go one by one and select the biggest shorelines and see whether it corresponds to select the biggest segments and see whether it corresponds to the shoreline of our interest. It's not necessary that the shoreline is captured in one single line segment. It can be multiple. Fortunately for our case, it is captured in one line segment itself, and therefore we'll delete all the other segments. Our shoreline line segment has been isolated and extracted now. In fact, it extends beyond our immediate area of interest as well. And if you are too finicky about it, you can even use the split tool, which I have demonstrated in my previous workflow as well. You just need to create two intersecting line segments where you basically want to cut off the existing line segment, and this would leave you with only the desired piece of shoreline. Anyways, now we can closely monitor the output, and you can see that it reasonably coincides with the satellite imagery base map on Esri. And as you know, our timeline is 2024 and we are currently in 2024. So the satellite imagery base map is relatively recent as well. That being said, one can also use a better tool to visualize our output, which is Google Earth, because it gives us certain advantages in terms of playing around with the timeline of the underneath base map of satellite imagery. In order to migrate this particular shoreline to Google Earth, we need to first convert it into a KML or a KMZ format. The layer to KML geoprocessing tool, which comes preloaded on ArcGIS Pro, would help us to do this. We just need to put in the input layer of our existing shoreline and save the output layer in a .kml format at our desired location. Besides that, we don't need to enter any other inputs, and we can run the tool, and it is very quick to run. Subsequently, let me show you the output on Google Earth. Remember that we had chosen to use Anjuna beach as our area of interest because we had already done Sentinel-2 analysis and we just wanted to use it for comparison purposes. Now, as you can see, the Google Earth Pro has loaded and it has a provision to select the timeline of satellite imagery by using the historical imagery button. So on the timeline as well as on the bottom of your screen, you will see the date of the imagery. So we have captured our shoreline from the January imagery. So as close as we can get to that, that would basically highlight to us whether our generated shoreline basically matches the surface features as seen from a optical imagery of satellite base map. I have also preloaded alongside Landsat 8 shoreline the output of Sentinel-2 shoreline from January 2024 as well. Given that the shorelines were captured from imagery just a few days apart in Jan 2024, as well as Google Earth's base map view is now in the early portion of 2024, the entire setting is ripe for comparison. As I navigate the shoreline, notice the green shoreline, which is from Sentinel-2, and the pink colored shoreline, which is from Landsat 8. Notice the similarity, differences, the potential reasons why, contemplate about it, and which method would you prefer. Personally, I see wherever there is a bias, more or less the shorelines are reasonably close to each other, but wherever there is a major bias, there is a clear reason behind it. Sentinel-2 imagery was analyzed using a water index, NDVI. Therefore, water features are very easily demarcated, and therefore the western edge of semi-water, semi-land features is where the shoreline of Sentinel-2 is. Whereas NDVI based Landsat 8 analysis shows a clear preference for purely land features, and therefore the shoreline is on the eastern edge of semi-land, semi-water features. In my view, Sentinel-2 or Landsat 8 is not the bigger question. The bigger question is which method you are using, and I think NDWI is the better method, because ultimately we want to spot the place where the land meets the sea, and NDWI is better placed to give you that particular answer in a right way. Nonetheless, the difference is not very large, and one can use either of those methods on either of the two types of imagery. That being said, I also want to bring to your attention that while we had done the last step of NDVI based Landsat 8 imagery analysis using a manual method because the automated tool wasn't working, because our shoreline of Goa was reasonably smooth and without any other terrain, deviations and properties, everything went smooth. But I had done a similar analysis on an area of interest on the east coast of India at a place in Odisha, which was affected by erosion. And you can see that the polygon to line output generates way too many attributes, which is 3754 distinct rows of line segments. Now that is very tedious to manage. I had thought of analyzing this particular region because Odisha as a state is also incredibly ravaged by cyclones and other natural disasters, and therefore its shoreline is particularly prone to suffer from massive deviations and most generally erosion. So this was the news article which prompted me, and I pursued it. And because I wasn't able to generate an automatic shoreline, I had created it using the manual method, but I was simply unable to create a shoreline from it because the polygons which were generated were too variable, too haphazard, of different shapes and sizes, and the polylines which were generated subsequently were even too tedious to manage, and it is virtually impossible for me to sift through all these features to identify the common shoreline line segments and to delineate it from the non-shoreline ones. So hence, this is just to inform you that the toolbox is not suited for analysis unless you have a particular version of ArcGIS Pro. Manually only works where the shoreline is of a reasonably smooth texture. With this, we come to the end. Thank you.